Okay. All right. Well, hello and good afternoon, everybody. We appreciate you joining us for our webinar, 5 Tricks to Improve ASP.NET Performance and Scalability. This has been a popular webinar in the past, an oldie but goodie. It used to be called 4 Tricks, but Ron added a fifth. So we'll get into that in due time. My name is Adam. I'm a certified Scrum product owner and the regional director of service delivery here. So essentially, I work as the liaison between our customers evaluating NCache and our internal software engineering team. With me is my associate Ron. Ron is our lead solutions architect. Not only is he's very hosts webinars like this, but he's very pivotal in the roadmap and strategic direction for NCache because he works very closely with the customers during evaluation and throughout the time that they're using the scalability product. So you're in good hands with Ron. During the webinar, if you have any questions, please feel free. Let us know. Ask as many questions as you would like. That's what we're here for. You'll notice there's a window pane in the webinar tool for you to type in your questions. I'll be monitoring that. So as I see questions come in, I'll stop Ron and make sure we get you all the information that you need. So with that, I'm going to turn it over to Ron and let you take it away.
Very good. Thank you, Adam. Thank you for the intro. Hi, everybody. My name is Ron. I'm one of the technical experts at Alachisoft, and I'll be your presenter for today's webinar. The topic, as Adam suggested, it's 5 tricks to improve ASP.NET performance and scalability. So today it's going to be a hands-on webinar where I'll talk about 5 different problems, 5 different bottlenecks that you typically see within an ASP.NET application, a web application, and then I'll talk about solutions, talk about scenarios, how you can basically handle those problems and help improve performance and scalability for your web applications. So since we have a lot to cover, so let's quickly get started with this. First of all, I'll build some basic concepts around ASP.NET as a platform. It's a very popular platform, very popular specifically for high traffic web applications as well. It's very scalable. It allows you to create a team of servers by making a web form or within a web server. You can also have a web garden scenario, and you can scale out nicely, handle tens of thousands of concurrent users and their associated requests. Here is a deployment of a typical web form within an ASP.NET web application. An application can be deployed on multiple servers. You can put a network load balancer in front of your web servers, and your end clients, your browser-based clients or any other clients which are accessing this application, they can go through the load balancer and then connect to the corresponding web servers. And then these web servers are working in combination to one another to help serve all your requests, and then there could be a backend database. An ASP.NET session storage if you're making use of session state. If it's the objects that your application is using, it's relying on some backend database system. Typically it's a relational database, so you would have a SQL or Oracle or any other relational database at the backend. And then you could have any mainframe or any other compute processes at the backend, or any other applications at this point. But this is a very simplified web form deployment for ASP.NET applications, where you have ability to create a web form where you can have one application deployed on multiple servers, and within these web servers, individual web server, you can also have a web garden scenario. So it's very scalable, as its architecture suggests. You can add as many servers to your web form, and you can introduce scalability factor within the application architecture. If your application load grows, you don't have to worry about one or two of your web servers being maxed out. At any point in time, you can introduce more servers to this load balancer and create a very scalable web form out of it. Next, I'll talk about scalability bottlenecks. Scalability in general is an ability to increase transactional load on your applications, and without compromising on the performance. So there's a throughput, which is how many of concurrent requests you can handle, and then there is a latency, how soon you can process a given request. So without introducing more latency, if you can increase the throughput, that system would be qualified as a very scalable system. So if ASP.NET platform is itself very scalable, so where exactly is the scalability bottleneck, where you have less throughput and high latency, or under scenarios where your request load grows, your application slows down? That's a typical problem, and that's what we define as scalability bottleneck, where under high load, your application would work fine when you have less number of users connected to it, but as soon as you keep on increasing more and more users, your application response times can go down. Now that you have bombardment of requests from the concurrent users, which have increased over a period of time, it can slow down your application, and it can crash it down as well. And it boils down to the resources of the systems which are handling those requests. With the help of web form, you can scale out, but you still have scalability bottlenecks, and it's usually because of these factors. And one by one, I'll talk about different scalability and performance bottlenecks within ASP.NET applications, and once we conclude all these bottlenecks, we'll talk about solutions and show you the actual examples as well. So first of all, we have two data storage bottlenecks. If you have noticed on this diagram, this is a very scalable platform, but behind the scenes there is a data source. It could be ASP.NET session state data source, or it could be a backend database server. Now, first of all, you could have application database point of contention, which is a bottleneck within the system. Your applications scale out very nicely, but they end up talking to a database server, which is right here, and that's usually not very scalable. Why? Because you cannot add more servers to a database at runtime, or in some cases it's not even a possibility. You can have an active passive scenario, but there couldn't be two database servers without partitioning of your data handling the same set of data, right? So it's very big effort to actually do that. So typically there's one database. You cannot add more database servers. It's slow to start off because it's not in memory. It's something which is driven through disk, and then it's very good for storage. That's what databases are good for. But as far as scaling out and having more and more request handling capacity, try to achieve out of database, that's not a possibility. Under high loads, your database would further slow things down, and that's our experience, that after a certain period of time, when your application load is growing continuously, your database can choke down, and it can actually slow down things. It would give you high latency under scenarios where you have huge transactional load. So databases, a relational database is one of the data storage bottlenecks, which we'll address in this particular webinar. Second is a bottleneck associated with ASP.NET session state storage. Now, if your applications are storing session state, these are the three modes that you can utilize offered by ASP.NET platform. So first of all, you can store everything inside the worker process. So in that case, you would have everything stored on the corresponding web server within the worker process on that web server. Now, inproc is storing everything on the same. It's a collection of session state. All the sessions are maintained in a collection within the process memory, but there are some issues. First of all, it cannot handle a web garden scenario, because if you have multiple worker processes, it requires that you have a sticky session bit enabled on the load balancer. So any session request which goes to one of the web servers, it has to be routed to the same web server going forward, and then within that web server, if there are multiple web worker processes, it would end up going to the same worker process all the time. So it's not an efficient utilization of your resources on the web form. One of the problem could be that your since session originated on one web server, within a worker process has to go, all the requests for that session has to go, those requests have to go all to the same worker process all the times. It is possibility that other web servers or worker processes are sitting idle because their users are not active anymore. Initially users were active, but one web server is taking more load than others because those users happen to be active on the application. And then if worker process gets recycled, and that's a typical case with ASP.NET worker processes, you would lose all the session state within that worker process. There's no replication or no reliability enforced if you keep everything in proc. Now, session data being lost is a very crucial issue. It's a big issue. It's not it's for mission critical applications, or even for regular e-commerce applications. If you lose a user data, that's going to hurt your business. So in proc, it demands sticky session. It cannot handle WebGarden, and it's not very reliable. If a worker process gets recycled, you would actually lose the session data within that worker process. Second option presented by ASP.NET is ASP.NET State Service. And state server hosts a state service. It could be one of your web servers, or it could be a separate box altogether. I have picked an example of a separate machine as a state server, but it's exactly the same. It's just a dedicated machine for hosting ASP.NET Session State. Now, what are the issues with this? Again, it's a single box, one machine hosting all your sessions. It resolves one problem. It takes the sticky session, load balancing out of the equation. It does not require sticky session, but again, it cannot scale out. It's a single machine, and there could be a time when it can hit capacity, and when that happens, it would actually choke down. It would slow things down. And then it's also a single point of failure. If state server, the service itself goes down, you would lose all sessions for your application, and that's not a recommended scenario as far as ASP.NET Session Storage is concerned. And then we have a SQL Server. SQL Server has the same issues that we've already covered as part of application data. If you plan on using SQL, session state inside SQL Server, it's not very ideal for storing blobs. It would give you performance issues because it's not in memory, it's disk based, and then it's not scalable. In some cases, it's also single point of failure as well. If database has to go down, or you need to perform maintenance on the database, which is usually a rare scenario, you wouldn't do that quite often, but that can bring down the system. So it's not something which is easy to maintain as well. So these are the issues with conventional ASP.NET Session State options. And like I said, I'll present a solution which is going to take care of all these issues. It would not be a single point of failure. It would not be, it would not be requiring you to have a sticky session bit. It can scale out. So that's something that we have planned for this particular webinar. So this diagram illustrates the storage-related bottlenecks, database, and ASP.NET Session State. Next, I'll talk about view state bottlenecks. For ASP.NET Web Forms, we also have a view state. For those of you who would like to know what view state is, I'm pretty sure everybody knows, but for the sake of completeness, for the sake of this webinar, view state is a client-side state management. It gets constructed on the web forms. If you have a lot of controls, widgets, text boxes, buttons, those would contribute towards a view state. And when a request gets handled, a response is generated. View state of those controls, it is a base64 encoded string, which becomes part of HTTP response. It's a hidden string, but it's part of HTTP response packet, and it goes back to the browser, and that's where it's stored. When you post back on the same page, it becomes part of your request packet, and that view state string is brought back onto the server side. Now that's how it's utilized. So it gets bundled with your request and response packets. It's never really used on the client end, and it's brought back to the server when you actually post back, and that's where it's actually needed. So it's a data which is needed on the server end, but it's not stored on the server end. It's sent back to the browser. Now, what are the issues with view state? So that's how view state works. View state is usually heavy, and I'll show you once we would actually move on to our hands-on portion, where I'll show you these features, NCache as a solution, and these features which would help take care of these bottlenecks. I'll show you the view state string. It is usually heavy. It could be from 50 kilobyte, 100 kilobyte, or even in thousands of kilobytes. It depends on what you have on your web forms. Now, if you have hundreds of kilobytes of view state per transaction for a web form, which is becoming part of your request and response packets one way or other, multiply it with millions of users, or millions of transactions for thousands of users. So you would end up with lots and lots of heavy view state traveling back and forth between your browsers as well as your web servers. So it can slow page response time down because your request packets and response packets are heavier to deal with. And then the most important one, it increases the bandwidth utilization costs that you pay in dollars, right? So your cost increases significantly when you have heavy view state traveling back and forth. So that's one of the bottlenecks which I'll cover as part of this webinar. And guys, please let me know if there are any questions. This is a diagram which illustrates view state. where it goes back to the browsers, and that's a point of contention because it becomes heavy over a period of time. If you have lots of view state and lots of user active, you would be dealing with huge amount of view state data, and that eats up your bandwidth between your web browsers and web servers.
I have a question about view state, Ron. You had mentioned view state is used with web forms. What if I'm using ASP.NET MVC?
Okay, that's a very good question. ASP.NET MVC architecture, it's a newer architecture and it does not utilize view state anymore, right? So view state problem would only occur in ASP.NET Web Forms. In ASP.NET MVC web applications, view state is not going to be there anymore, right? So it's not utilized because web forms have an architecture where you have controls and there's a code behind. There's no way you can store the state of those controls because HTTP protocol is stateless, and a web form which is generated, rendered, it has to store its view state. But MVC is a model view controller architecture, so it does not utilize the legacy view state architecture anymore. So you would not see this bottleneck in MVC. MVC is already handled for the view state, and this is why it becomes more important. What if you have ASP.NET Web Forms? You're still using the older technology for web applications, and now you have to deal with view state. And this is exactly what I'll cover. For ASP.NET Web Forms use case, we have a solution where you can also optimize the view state bottleneck within your application. You can completely get rid of it. And then this covers our third bottleneck. Fourth bottleneck, like I said, we have 5 tricks, right? So we'll cover 5 different problems, and then we'll present 5 different solutions to address those problems. There could be extra page execution bottlenecks. Usually with ASP.NET applications, and this applies to MVC as well as for web forms, there are chances that your page output does not change, right? You could have an e-commerce application which is displaying product catalogs, some orders information, some new categories, and you keep on getting the same page content again and again. So it's almost static, right? Or it could be the page itself static, or portions within the page which are static, which are not changing very frequently in your environment. So between requests, if you're getting requests from your users, your ASP.NET application would execute those pages regardless. So if a request comes, it's a HTTP stateless protocol, it has to render a response and generate that response. Now this can slow down your page responses, specifically if there's a backend database involved. One request, it gets executed, and then you apply that request to the backend database. You fetch some records, and then a response is rendered. And again, the cycle has to go through again. If the same request comes again, you have to follow the same routine. And although the content is exactly the same, it's not changing. So that's another bottleneck where you're dealing with static content and you're executing the same requests, same utilization of infrastructure and resources, CPU, memory, and database resources are consumed for every single request that comes onto your HTTP, onto your ASP.NET application. So it is going to reduce the capacity. So it's the extra execution cost for your infrastructure, and it can slow down page responses where you can, where you're not able to deal with the static content, which doesn't have to be executed again and again. So that's our fourth problem. Yeah, that within ASP.NET applications, you deal with extra page execution times, and this is fairly for the static content within the pages. Now, this diagram completes our completes this section as well. We have extra page execution on the static output, we have the heavy view state, we have database server as a contention, and then ASP.NET session state. Now, fifth problem is with a very specific scenario where you have SignalR. SignalR is a very popular technology these days. It's usually for your client-side browsers, if there are JavaScripts, and if you have ASP.NET SignalR implemented on the server end, you can invoke the client-side logic, client-side methods, instead of clients going through a request and response model. A typical example would be if your SignalR applications, usually if there are high transactional and high traffic applications, there's a new content that needs to be pushed to the clients. Content would only be pushed once client sends a request, right? If there are new orders, new products, or new messages, if it's a chat system, those new messages would only be delivered if the client actually sends a message. sends a request and a response is rendered. So typically client, the JavaScript within the client end, you can implement a long polling, right? You can implement a long polling in such a way that if after certain intervals you refresh that page. So instead of doing that, you can ask your ASP.NET applications to implement SignalR. It's a very simple API, and then you can invoke the client-side methods automatically when new content needs to be pushed. So it's ASP.NET application's responsibility to actually take care of new content being pushed to the client end. Now, what are the bottlenecks with it? First of all, with ASP.NET applications, once you have a web form, you need a backplane for ASP.NET SignalR, because SignalR utilizes a WebSocket concept where instead of HTTP statelet protocol, it actually have a connection to the end clients, right? So in that case, if a web server has a client connected, it would have connection to only one web server, right? And it could have certain number of clients connected to it, but other web servers are not able to transmit their messages to all the connected clients. So they make use of a backplane where all the messages are sent to the backplane, and then backplane in turn sends it back to all the web servers, and they in turn send it to all the clients which are connected. So what are the issues with ASP.NET SignalR backplane? First of all, SignalR backplane and SignalR itself is used for high transactional and it's high traffic and high transactional application. It needs low latency and high throughput. Now that you have a backplane, it's designed in such a way that it would actually, every message has to go to the backplane then send it to all the web servers, and then web servers send it to all the clients. So backplane has to be super fast and very scalable in nature. If your backplane, and typical options are database or messages queue, they can in conditions they can give you high latency. They would not be as fast as your application load is coming in, right? So you may be dealing with huge amount of SignalR messages, but you don't have infrastructure on the database end or on the message queue end to deal with that high transaction. Redis, that's another option, but that's not native.NET, right? So if you plan on using Redis, it takes care of the scalability issue, but it's not a native.NET. And if you're coming from an ASP.NET background, you have SignalR, which is again an ASP.NET Core technology. Redis would not fit into the stack right away, right? So that's another problem. And then SignalR backplanes are usually not that scalable, right? If you plan on using SQL Server or database for that, under high volumes, it can again choke down. So that's a very specific use case where SignalR, it's slow. In some cases, it's not native.NET. And in some cases it's not going to scale out. There are many options that you can choose from, and this is one of the primary bottlenecks with applications which are specifically using ASP.NET SignalR. So this completes our 5 bottlenecks. This diagram covers it. I'm just going to go over it one more time, and if there are any questions, please let me know, and I'll take care of those. So first of all, we talked about database storage bottlenecks. Any objects, any data that belongs in the database, it's slow, it's not scalable, it's single server. You cannot add more servers. ASP.NET Session Storage in proc has issues, sticky session. It's not scalable and it's not very reliable. State server is again single server, not scalable, single point of failure as well. Database is slow, it's not scalable. So ASP.NET Session State has all the issues. Then we talked about view state becoming heavy, eating your bandwidth between browsers and the web servers. It's slow as well because your packets, request and response packets, become heavier. And then we talked about extra page execution for the static output, although the output is not changing, but you're still executing because that's how ASP.NET request and response model works. And then you have a SignalR, the backplane. It's not very scalable and it's not fast enough to deal with huge transactional load. Any questions so far? Because from this point onwards, I'll be presenting different features that you can use to address all these problems one by one. Any questions? If there are no questions, then I'm going to quickly move on to our solution. Solution is very simple. It's the use of in-memory distributed caching system, such as NCache. NCache is the main distributed caching product offered by Logisoft, and I'll be discussing all the features that you can use to optimize your ASP.NET, 5 different features to be precise. So first of all, let's talk about what is an in-memory distributed caching system. It's a cluster of multiple inexpensive cache servers. So it's a team of servers that you've joined together in a logical capacity. You pool their memory and CPU capacity, and you have multiple servers working in combination to one another. Then you can synchronize cache updates across all servers. That's one of the characteristics. Although there are multiple servers, but all updates are performed in a consistent manner, in a 100% synchronized manner. Any update on one server is visible to others, and vice versa. You can scale out for transactional as well as for memory capacity. As you add more servers, you grow the capacity of how many requests you can handle. So that makes it a very scalable system. And then it also replicates data for reliability. So this is the general requirements, but there are more specific ones as well. There are many other characteristics, many other features which are built into this distributed caching product. But this is generally top four characteristics of a distributed caching system. And this is how it is deployed. You can already see that there are many caching servers, right? 3, 4, 5. And is there a question, Adam?
Yeah, I just have a quick question about what are the characteristics of a distributed cache that actually improve the performance? If you could touch on that briefly.
Okay, very good. So there are a few characteristics. First of all, it's in memory, right? So because of in-memory storage, it's super fast. It's stored on the memory. So fetching anything or adding something onto the memory is super fast in comparison to database. Then additionally, it's a team of servers, right? So your request load gets distributed. So if you're about to handle say 10,000 requests, and if you have two servers, one server is handling 5,000 and another is 5, you take half the time in comparison, right? So it's more of a scalability where your load is distributed between number of servers, and a request which usually, for example, for 10,000 requests, if you're taking say 5 minutes, you would now take 2.5 minutes because those requests are now distributed between servers. So that's another factor where under high load, where usually systems choke down, it would not compromise on the performance. It would stay up and running and would not slow down performance, and in comparison, it would just increase your throughput as well as low latency. So in memory, and then ability to add multiple servers, and then ability to add more servers on the fly. These are the characteristics which would help improve performance in general. So this is our distributed caching platform, right? So you have a tier of caching servers between your web apps and the database, and you can see this is already very scalable. Now compare it with this diagram right here, where they were all talking to database tiers directly. Now you have, or backend data sources or other form of ASP.NET SignalR Backplane or a session storage. Now you have intermediary tier. Web form is very scalable. This NCache tier is very scalable, and then you have a backend database as well. It's not a replacement of your existing relational databases. You can use it in combination to your relational databases as well. Preferred platform is 64-bit. All Windows environments are supported 2008, 2012, 2016, and only prereq for NCache is .NET 4.0. It's 100% native .NET, and that's where it has its main edge, where it's primarily utilized for .NET, and you can also run Java applications, but main set of applications are from the .NET stack. I'll quickly show you some performance benchmark numbers, and then we'll quickly move on to our 5 different tricks to handle. Why is it more scalable and how it actually exhibits? It allows you to. There are many caching topologies. There is an active-active, replicated topology, active-passive mirroring topology, and then active-active partitioned and partition replica topology. So based on these topologies, you can see the performance numbers. Partitioned cache from 1 to 2 servers and 2 to 3 servers, and from again 3 to 4 servers, you've almost doubled your cache load. Here's a good example. 2 servers are handling about 50,000 reads and 32,000 writes per second, and 4 servers are now handling about 96,000 to 100,000 reads and about 64,000 writes per second. So these are the tests which are conducted in our QA environment, and we can see that it's increasing in a linear manner. As you add more servers, it actually increases the capacity of how many requests you can handle. Alright, so let's get started with the actual demo of the product, where I talk about these features that you can utilize, and one by one we'll address all the bottlenecks that we initially discussed. Alright, so I'll quickly go ahead. I have 2 servers. I'll just create my cache on 2 caching servers. I'll be using NCache management tool. Since this webinar is more focused on ASP.NET features, so I'll just create a simple cache. There are other webinars which are actually focused on NCache cache configurations, different topologies. So I would recommend that if you guys are interested in those, you can also review those on our website. So I'll just create a cache. Let's name it ASP.NET cache. It's not case sensitive, so let me just use uppercase for now. Partition replica cache is the most suited topology for ASP.NET applications. Async is a replication option. I'll just keep async because it's faster. And here I specify the servers which are going to host my cache cluster. So demo 1 and demo 2 are two servers which are going to host my cache. You can create multiple caches for different uses. One cache for session state, one cache for view state, and one cache for object caching as well. So it's entirely up to you. This is the TCP/IP port which is suggested for the communication. I'll just pick this one. Size of the cache cluster is per server. If you have two servers, it would use twice as much size. It would allow you to have 2 times the size, 1 gig on server 1, 1 gig on server 2, and so on and so forth. I'll just start this cache, and I'll also auto start so that each time the server gets rebooted, the cache automatically gets started. And that's it. That's how simple it is to configure a cache cluster with the help of NCache. And by the way, we also have PowerShell tools, command line and PowerShell tools as well, to achieve the same management capabilities. I'll add my machine as a client because that's where I plan on adding all the applications. It's just updating the configurations to connect to this cache. That's it. I've already opened the statistics, so I'll just open monitor cluster so that everything is configured fine. And from that point onwards, I'll actually get started with this. So we're good. No load is being simulated at this point. So I'll actually get started by running a small stress testing tool application, and just to verify that my box is able to actually connect to this cache. This is a tool which simulates some dummy load on my cache cluster. There you go. So both servers are taking requests from the clients. From the client 1 application is being run. So I think we're good. So I'm just going to close this down. Alright, so first of all, I will actually show you, these are the 5 features that I've planned. We have data caching for database bottlenecks. Now it works in such a way that NCache is a very scalable platform, right? So it's not a single source. There are multiple servers which are working. There's a team of servers and it's in memory. So the 2 issues with the database bottlenecks were it's not fast. NCache is super fast in comparison. Database cannot scale out. NCache can scale out to start off. You can have 2 servers, and then you can add more servers on the fly. It allows you to add another server on the fly, and you can increase the capacity at runtime. So this is our first feature, and it requires API calls to be introduced, and here are our API calls. I'll showcase this once with the help of a sample application as well. Then I have session state. You can use the session state. Session state, again, it's very scalable. You don't need sticky session bit. You can have multiple servers host your session. Session state becomes outside the application process. You can optimize the serialization overhead, and then it's very reliable, very scalable. Any server going down would not cause any downtime or application data loss. So these are the benefits. So it's no code change option. It does not require sticky session bit. It's very scalable. Sessions are replicated across servers, so there's no data loss, no application downtime in case of any web server going down or NCache server going down. This is completely covered within the protocol. View state is again a provider. We store view state on the server side. We don't send it back to the browser, and I'll show you how it helps improve the performance. And then SignalR, we have a very scalable .NET based SignalR backplane implemented. So your backplane is super fast because it's in memory. We're using pub/sub model behind the scenes, and then any request going to the backplane is transmitted to all the connected web servers. It's very reliable. It gives you monitoring capabilities. It's super fast, and it's native .NET. And then output caching, we again have a provider. You don't have to execute your pages again and again. You can cache the output contents, page outputs, and then you can provide the page output as soon as a new request comes in, which is again requesting the same data. So this is what I've planned in. So let's get started with our application data caching and ASP.NET session state caching, how to go about it.
One quick question for you, Ron. How difficult is it to set up the 4 features: session state, view state, output cache, and SignalR? Like, what's the level of effort involved to use all those features
Got
at
it.
once.
Got it. Okay, so for data caching, it requires some dev, perspective into it, where you need to introduce, calls to connect to NCache. So you would introduce NCache cache wrapper, right? It's your wrapper which is actually using NCache APIs, similar to on the lines of data access layer, where you interact with database. Now you would have a caching layer where you would interact with the caching. But these features are all no code change options, right? So these are just mere configurations. Session state, view state, SignalR, output cache. This is something that I'll showcase in this particular section. Next 15 minutes, I'll show you all these features, and that's exactly the kind of time that you need to set up. And skill set, any system admin level, resource can actually set this up, and they can review how this works. So these are all completely no code change options driven through configurations. So let's quickly get started with this. I'll start with the ASP.NET session state, and I will cover data caching with the help of one sample. Right, so I have this sample application right here. By the way, these are available in our on our website, as well as they come installed with NCache as well. So the way I've designed this sample actually uses our session state. All you need to do for ASP.NET session state is to include this library right here, which is being highlighted at this point. Right, it's a lachi.ncache.session supervisor. That's the version of our latest product, 4.8. That's the version of NCache, the latest version. And then you need to replace your existing session state tag with NCache. As you can see, we have NCache session supervisor timeout for each session. If a user is idle for 20 minutes, it would automatically remove this session from the cache. And then there are some settings, for example, session locking. These are tuned for best usage already. All you need to do is provide the name of the cache. Now that my box can connect to it, right? I've already figured out, verified that my box where this sample is running, it's able to connect to the cache based on the configurations that we've done. We have added the box under the client nodes. I just need to specify the name of the cache that I want to connect and create the session. So let's actually get started with this, and that's all what you need in order to set up ASP.NET sessions. I think that further reinforce what we've just discussed, that it's very easy to set up. So you need an assembly tag, you need a session state tag, and it picks it up from that point onwards. So it will get started, and I will quickly show you. Let's clear the contents. Actually, it's already cleared. Let's open a tool which says dump cache keys, so that I show you the sessions being added. It actually dumps all the keys, and you can already see there is a session ID and an NCache test keyword added, and there is an application which is actually using sessions out of NCache. I will just run another instance of the same application in another browser window, just to show you that there's another session object which gets created. So there's a new session which just got created, and then you should be able to see the session on the server end as well. There you go. Now two sessions, and notice the session value here is replicated on this server, and session value here is replicated. Both servers are equally utilized, and there are backups as well. So it's very scalable, very reliable, no sticky session bit needed, easy maintenance, and everything without any code changes. So that covers our first sample application, and this would completely take care of all the issues that you would usually see with ASP.NET session state storage. It's better than inproc because it's more scalable, more reliable. It's better than session state server because it's clustered, multiple servers. It's more scalable, more reliable, no single point of failure. It's better than SQL Server option because it's not slow, it's in memory, and it's very scalable. You can have multiple instances run as well. Now this application, if I just quickly close it down, it's also being used for data caching, right? So what I've done here is I've added two more assembly references to consume the data caching functionality: alachisoft.ncache.web and alachisoft.ncache.runtime. That's all what you need in order to access NCache client-side libraries. Now for data caching, you can initialize the cache. You need to add these namespaces: alachisoft.ncache.web.caching, and additionally you can also add alachisoft.ncache.runtime. But at the minimum, you need just this one. You initialize the cache, and let me just make this as a startup page. and then you add objects by calling cache.add. You add a customer, insert the customer by changing a value, for example changing the age to something else, and then retrieving the customer again, getting the count of the cache.count, and then you're removing the customer, and then you're also running a load test, which is simply simulating the same request again and again. So I'm just going to run the same application one more time, but with a different page in question this time. Alright, so there has been an issue. I'm not able to spawn. Let me stop this first and then try again. If it doesn't work, I'll just change the browser. So it didn't work this time as well. Let me just change it to Internet Explorer. That's an issue that I'm getting. Alright, so now let's simply add an object, and if I bring you the get cache count, it would now have another key into the cache, which is the object. Sorry, I think I used a different cache name for it. Yeah, that's the problem. So I was actually using some other cache. Yeah, that's the problem. So let me just direct it to ASP.NET Cache, the one that I have on the server end. And we're using a local cache right here. So let me just close it down to add an object, customer added. So I'll go to the server end and run the cache commands, and along with sessions we would now have a separate object of the customer as well. By the way, you can have a separate cache for for example for view state, let's create a separate cache, so you can also do that. Or for output caching, you can create a separate cache. All you need to do is just go through the same steps and you would see another cache cluster here. But for the sake of this webinar, I have just one cache because it's easier to demonstrate. I'll just insert the customer. It's inserted. I'll retrieve the customer back, printed it. Items in the count 3, 2 sessions, 1 customer. I'll just remove this object, again take the count, 2 items, and then I can start the load test, which I wouldn't do at this point because it would take time. But you can see the idea here. Now this would take care of all the database related bottlenecks. It's not going to be slow. You're dealing with your custom objects in the cache. It's super fast in comparison. It's very scalable, and you can still use the database in addition to this. There are lots and lots of features within this section. You have database dependencies, you have data access layer providers, you have MapReduce, entry processor, then you have database synchronization features. So it's very feature rich on this aspect. So this covers our 2 features. Next I'll talk about view state. View state is for ASP.NET Web Forms, as we've already established. Again, it's a provider model. There's no code changes required. All you need to do is you need this assembly right here. Others are actually redundant. That's it. That's all what you need. Lachisoft and the content optimization version 4.8. Next, you set up a content optimization segment. So I'll start off this sample with view state turned off. This is the default option. Provider is plugged in, but the enable view state flag is set to false, right? So there are many features here. You can set up a threshold of the view state, but I'll talk about it in a bit. But I want to first show you the view state without NCache, and then compare it with view state with NCache and show you the difference, how it works. Alright, so we have view state caching.aspx. So this is a web form with a grade on it, and I have gone through 4 different pages, so there may be 4 different view states created. Actually, we're not using any view state provider at this point, so I just need to show you the page source. Let's stick to 4th page and see the view state. Okay, this is the value part of the default view state without NCache, right? So I'll just come here and create a text document, and you can see the view state. I'm sorry, I actually clicked. I wanted to word wrap it. Yeah. So this is the default value, ASP.NET default, and then I will show you once I turn on NCache. So that's next. So all I need to do is set up our assembly, set up this section, and then turn this flag to true. Save it and then run it again. So it's driven through configurations. Now we'll show you the view state, and view state would actually cached on the server end. And the way it works is that we actually keep the view state on the server end. We don't send the view state back to the browser. We send a small token back to the browser, which is an encrypted cache key. And when you post back, we actually fetch the view state from the server end, saving expensive trips over the network. Your view state becomes smaller in size. And now I'll just show you the view state source, and this is the value with NCache. You can see the product view state is now shrunk to this size, and if I just compare it with the view state that you previously had, that's the difference, right? So that's what is traveling back and forth. But where is the view state? If this is what is shrunk to it, but this is not the view state anymore, it's the key of the view state. Actual view state is right here. Now we would have a few view states shown here. Anything with VS, this is the key which is encrypted and sent back, and then the object part of it has the data. When your application user posts back on a web form, the view state key comes to the server, and then you make a cache request, which is very fast. It gets you the actual view state. So smaller view state overall improves the performance. You're dealing with smaller payload, and then most importantly, it reduces your bandwidth utilization costs. And that's very important these days when you have everything pay as you use it. So your bandwidth costs would go down significantly with the help of our provider. But primarily it's there to implement enforce performance and scalability bottlenecks. Any questions on the view state? This is pretty evident what we do as part of benefits. Next I'll talk about SignalR, and then finally I'll talk about the output caching. SignalR backplane, right? So we have a sample just for that. What we've done is we have Microsoft sample for SignalR, and then we've used our backplane as part of this. So all you need to do, I've just added some keys here. For example, I have a chat application which is using SignalR, and it is, if you look at the chat hub.cs, it's actually broadcasting this particular send method. And then if you go to the definitions of this, it's actually I'm not able to do so. But Microsoft ASP.NET SignalR library is actually being consumed as part of this method, and then within the startup.cs I have global host.dependency resolver.use NCache, and then I have cache name, right, which is being read from the app settings, and then I have the event key, which is a channel that this application wants to subscribe to. So for applications deployed on a web form using a backplane for NCache, they need to come up with same event key. One application has to have same event key across the board, and then the cache name should be the one that you're actually using. And if I just run this, it would again use the same ASP.NET Cache. Now that I've made the changes, let me just verify. ASP.NET Cache for SignalR use case as well. Alright, so default, and it would ask me to right, so let me just run my sign in. It's a chat application, right? So I'll just see if I can use this and create another, and let's say Alex, and right now if I come back to the SignalR side of the things, Alex's message is already sent here, and you could see the same messages right here. So it's actually transferring messages at runtime using the SignalR backplane. With NCache, the benefits over other options, database, NCache is super fast, is very scalable. Message bus in Redis, and NCache is native .NET in comparison to Redis. It's more scalable. Its clustering is more mature. It has 100% peer-to-peer architecture. As a matter of fact, we have a full comparison with Redis. NCache is definitely a better option. On top of it being the same stack, it's 100% native.NET, and it would be preferred for ASP.NET applications which are using the SignalR. So that covers our SignalR. It's one line of code that you need to use, and it would simply optimize. This is what you need. You can simply provide the cache name, and then we have a provider implemented for Backplane that gets utilized right away. All right, so next, I think this is the last feature, is our output cache. The way it works is that it would actually, let's just talk about some details here. The way it works is it actually allows you to cache the static content of the ASP.NET pages into the distributed cache, and then you don't have to re-execute your pages. It's not going to involve database for the content which it already has cached, so it would improve performance by saving trips to the database. So performance is improved, and then it also saves extra execution cycles on the server. So servers are not going to be maxed out. The web servers are not going to be maxed out executing something which is already executed. So as long as your output is not changing, you're in good hands. So all you need to do is you need this assembly reference. You don't need any other, but this is the one that you need at the minimum. And then you set up output caching section and output cache provider. This is the provider assembly. Version is 4.8, and then you specify the name of the cache, which is ASP.NET Cache. It's not case sensitive, so I'm not too bothered about the mixed case. So ASP.NET Cache, and then if I run this sample, one other thing that you need to decorate your ASPX pages with the output cache directive. Right, so this is the directive that you decorate all your pages with, and then these pages, if the exact same param is being passed to the request header here, it would actually not execute it. If it would execute it for the first time, go through complete execution cycle, go to the database, create a response, and then cache it, and then response is given to the end user. If the same request comes again, it would check first in the cache. If it's found there, same request, it would be retrieved directly from the cache. It would not even go to the database. That's where it improved performance. And then it's very scalable. Multiple requests can be managed, and then it saves your extra execution cycles on the web servers as well. Since we're almost at the 1 hour marker, so this is what you need in order to set up all these features. So let me just quickly reiterate. We have talked about 5 different tricks. We talked about data caching. This is faster than database, more scalable. We talked about session state, no code change option, more scalable, faster in comparison, and better than all the existing options. We talked about view state only for web forms, how view state compared with typical ASP.NET versus NCache, and then we talked about SignalR and output caching. So this completes our 5 different options to improve ASP.NET performance and scalability. I'll hand it over to Adam from this point onwards.
I do have one quick question before we wrap up. What about using output cache with ASP.NET MVC?
Yeah, that's a good question. Okay, so unlike view state, ASP.NET output cache provider for NCache can be used with MVC as well as with web form. As a matter of fact, all the features that we discussed are applied on MVC as well as on web forms, except except the view state. View state is something which is only part of the legacy web forms. Other than that, you can use all the other optimizations with MVC as well as with view state.
Cool. Perfect. Thank you. Thank you. And yeah, thank you for the demonstration, Ron. And we thank you, everybody that joined us, for setting aside some time in your work day to learn about NCache. All of our NCache editions are available for download on our website. If you want to actually implement it in your environment and test it out and see what it's all about and put your hands on it, it's on our website. We work very closely with our customers during the evaluation, so yeah, lean on us, leverage us. We have solutions architects that are available to talk about your use case, help you get configured, and see if NCache might be a solution for your environment. But again, thank you for your time. Thank you for joining us. We hope to see you all again soon.
Thank you, guys.
Thanks.